Hello, Miss Thinker here. Your daily source for mind-blowing facts, forgotten history, and powerful motivation. Every star you see in the night sky, including our very own sun, is part of a magnificent and endless cosmic cycle. Stars are born, they live out their lives, and eventually they die. But their death isn't a true ending. In a way, it's a spectacular new beginning. Tonight we're going to embark on an incredible journey tracing the full life story of a star. From its fiery birth inside a vast cosmic cloud to the powerful way it transforms the entire universe at the moment of its death. All stars begin their existence huddled inside enormous clouds of gas and dust known as nebulae. These stellar nurseries are impossibly vast, sometimes stretching for hundreds of light years across space, and they hold enough raw material to forge thousands, even millions of new stars. One of the most famous examples is the beautiful Orion Nebula, a cosmic cradle where new stars are being born right now, a sight we can witness from our own backyard. Within these immense clouds, gravity gets to work, patiently pulling tiny particles of gas and dust closer and closer together. As this material collapses inward under its own weight, it begins to spin and heat up, eventually forming a dense, glowing ball of hot gas called a protostar. At this stage, it's not quite a true star. It's like a stellar embryo, gathering mass and getting hotter, but it hasn't yet ignited the nuclear engine that will power it for the rest of its life. The defining moment comes when the pressure and temperature at the core of the protostar reach a critical point about 15 million degrees Celsius. At that incredible temperature, something amazing happens. Nuclear fusion begins. Hydrogen atoms are forced together so violently that they fuse to create helium, releasing a tremendous burst of energy in the process. This energy pushes outward as light, heat, and radiation. The moment fusion ignites, a star is officially born. Our own sun went through this exact same process about 4.6 billion years ago, lighting up our corner of the solar system. Once fusion is underway, the star settles into the longest and most stable phase of its life, known as the main sequence. During this phase, the star exists in a state of perfect balance. There are two powerful forces locked in a cosmic tug-of-war. Gravity relentlessly tries to crush the star inward, while the immense energy from nuclear fusion pushes outward. As long as these two forces remain balanced, the star shines steadily for millions, or even billions of years. A star's lifespan is determined by its mass. It's a bit counterintuitive, but the biggest, most massive stars are the ones that live the shortest lives. They burn through their nuclear fuel at a furious rate, shining incredibly brightly but exhausting their supply in just a few million years. In contrast, smaller, less massive stars like red dwarfs sip their fuel slowly and can live for trillions of years, far longer than the current age of the universe. Our sun is a medium-sized star about halfway through its roughly 10 billion year main sequence lifetime. But no star has an infinite supply of fuel. Eventually, every star will run out of the hydrogen in its core. When that happens, the delicate balance is broken. Without the outward push from fusion, gravity starts to win the battle. The core begins to contract and heat up even more. This new heat causes the star's outer layers to expand dramatically, swelling up to hundreds of times its original size. The star transforms into what's known as a red giant. When our sun reaches this stage in about 5 billion years, it will grow so large that it will likely engulf Mercury, Venus, and possibly even our own planet Earth. This isn't an explosion, but a natural and profound transformation in the star's old age. What happens next, how a star ultimately dies, depends entirely on its initial mass. For small and medium-sized stars like our sun, the end is relatively peaceful. After the red giant phase, the star doesn't have enough mass to trigger a massive explosion. Instead, it gently puffs its outer layers of gas away into space. These expanding layers form a beautiful, intricate structure called a planetary nebula, which glows for a few tens of thousands of years as it dissipates into the cosmos. Left behind at the center is the star's incredibly dense and hot core, a remnant known as a white dwarf. A white dwarf is typically about the size of Earth, but it's so dense that a single teaspoon of its material would weigh several tons. Over billions of years, this white dwarf will slowly cool and fade, becoming a cold, dark cinder in space. Massive stars, however, go out with a bang. Their deaths are some of the most violent and spectacular events in the entire universe. When a star at least 8 times the mass of our sun runs out of fuel, its core collapses catastrophically. This collapse happens in a matter of seconds, triggering a rebound shockwave that tears the star apart in a titanic explosion called a supernova. For a brief period, a single supernova can outshine an entire galaxy of billions of stars, releasing more energy in an instant than our sun will in its entire lifetime. What's left after this cosmic explosion depends on the star's original mass. The core might collapse into an ultra-dense object called a neutron star, where matter is so compressed that protons and electrons merge to form neutrons. A neutron star is like a city-sized atomic nucleus. If the original star was even more massive, gravity overwhelms all other forces, and the core collapses infinitely, forming a black hole, a region of space-time from which nothing, not even light, can escape. But here's the most incredible and profound part of this entire story. Supernova explosions are not just acts of destruction, they are acts of creation. When these massive stars explode, they forge and scatter heavy elements across the galaxy, elements like oxygen, carbon, iron, and even gold. These elements, cooked in the hearts of stars and blasted out into space, become the raw material for the next generation of celestial bodies. They mix with interstellar clouds to form new stars and new planets. And this is where the story of stars becomes our story. Every single atom in your body, everything that makes you who you are, apart from hydrogen, was created inside the fiery core of a star that lived and died long ago. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of it was forged in a stellar furnace and scattered by a supernova. You are quite literally made of stardust. The gas and dust released from dying stars drift through space, eventually gathering to form new nebulae. Within those nebulae, new stars are born. Those stars live their lives, create new elements, and die, enriching the cosmos further. The universe is in a constant state of recycling, a grand cosmic cycle of birth, death, and rebirth driven by the lives of stars. They are not just distant lights in our sky. They are the engines of cosmic evolution. They build galaxies, create the elements, and ultimately make life itself possible. Every sunrise we witness, every breath we take, is a direct connection to that ancient stellar past. The story of the stars is not separate from us. It is the story of our own origins. If you enjoyed this journey through the cosmos, make sure to subscribe and turn on notifications for more deep dives into space, science, and the incredible universe we call home. There are so many more secrets waiting to be discovered. Thanks for watching.